Welcome to an example in which we're trying to find the sine of alpha plus beta. So they're telling us that the cosine of alpha, I'll just call it A, is the square root of 2 over 7. And the sine of B, beta they say, but it's just a Greek B, is the square root of 5 over 3. So I'm just taking it right there and right there. Okay, and then they want me to find the sine of alpha plus beta. How am I going to do that? Well, let's write out the sine of A plus B. In fact, I think I'm just going to make that a capital A. It just works better for me. Sine of A plus B. Okay, right, that's what they're asking. Sine of alpha plus beta. Find that. So what is the sine of A plus B? Well, if you go down to the formula sheet, the sine of two angles added right here. There it is. Okay, and so that's going to be sine, cosine, cosine, sine, A, B, A, B, and this sign that's in the middle is the same. Same sign in the middle. Anyway, so there we go. So we can find the sine of A plus B, which is what they want us to find. We just have to find these four pieces: sine of A, cosine B, cosine A, and sine B. We've already got cosine of A right there. That's root 2 over 7. We've already got sine of B right there. That's root 5 over 3. But what we don't have is sine of A and cosine of B. If we can get those two, then we can put this thing together and finish the problem. So how are we going to do that? How do we get the sine and cosine of those angles, right? We have the cosine of A, but we don't know the sine of A. And we have the sine of B, but we don't know the cosine of B, right? So you see what we have? We have the cosine of A, but not the sine, and we have the sine of B, but not the cosine. How are we going to get those other things? Well, we can just draw a first quadrant triangle. So let me do that. So I'm going to put a quadrant system here. And see how they said first quadrant angles? So therefore, this is a first quadrant. So I'm going to do one over here for A. This will be the A side. So I'm going to make a triangle like that. And I'll put angle A right there at the origin. And I'm going to do what it says. Now remember the so let me write the steps for stuff. So we need to in fact probably be best if I step 1, draw triangles in first quadrant for A and B. So over here, I'm going to draw another one. And this one's going to be for B. Okay, so step 1. So, and then step 2, remember SOHCAHTOA. So the cosine, let's go back to it. The cosine, remember what cosine is? Adjacent over hypotenuse. So this is A, so this is the opposite side. This is the adjacent, and this is the hypotenuse because it's across from the right angle, huh? So cosine of A, adjacent is root 2, so this is root 2. Hypotenuse is 7. This is 7. Let's go to the B. Sine of B, sine is opposite over hypotenuse. So the opposite, here's B. Here's the opposite side, the adjacent side, and the hypotenuse. For that one, let me get rid of these arrows in here. Okay, so the sine of B, opposite, root 5, so this is root 5, over hypotenuse, which is 3. This is a 5 here. Root 5 over 3. Okay, so we're missing a side in each of those triangles, aren't we? So how do we find that other side? I think you know, right? Then you use A squared plus B squared is C squared for both of them. So I'll go over here and go a squared plus b squared is c squared. And the main thing you got to remember, the c is the one that's alone. So, I'm sorry, it's the one alone. It is alone, but it's also the hypotenuse. So this is c, and this is c over here. So this is the 7 squared. So we've got root 2 squared, because one of the sides is root 2 squared, plus the other side squared is 7 squared. Root 2 squared is just plain 2, isn't it? Because the root just cancels the square. Plus b squared is 49. Subtract 2 from both sides. B squared is 47. And then root it, so b is the root of 47. So this other side here is the root of 47. And then we're going to do the same thing over here. Again, a squared plus b squared is c squared. The c is the 3, the hypotenuse. And the a and b are interchangeable, doesn't matter. Call it a squared plus root 5 squared, or the other way, it doesn't matter. A and b can be switched. This is a squared. These cancel, right? It's going to be just 5. That's 9. Subtract 5 from both sides. Boom. A squared is 4. Root it. A is 2. So that comes back here. This other side here is 2. So now we've got all three sides in both triangles. And now find what you need by SOHCAHTOA. Back to SOHCAHTOA. What do you mean? What do we need? Well, we were trying to find cosine of B. What's cosine of B? Go to the B. This is angle B here. Cosine in the B. This is the B triangle, right? This is angle B triangle. This is the angle A triangle over here, right? So the B triangle, cosine of B, cosine, remember, is adjacent over hypotenuse. So adjacent over hypotenuse, it's 2 over 3. B is 2, cosine of B is 2 over 3. In the B triangle, cosine, adjacent over hypotenuse, is adjacent over hypotenuse, 2 over 3. And then in the A triangle, sine is opposite over hypotenuse, so opposite over hypotenuse. So it's square root of 47 over 7 in the A triangle, right? The A, because it's sine of A, is opposite over hypotenuse. All right, so there it is. Now we just got to, I'm going to grab it right here and bring it on down. Bring it way down, I guess, where we have room. What was it? Root 47 over 7 times 2/3. Plus, and then root 2 over 7 times root 5 over 3. Take that right? Root 2 over 7 times root 5 over 3. Yeah, so now we just need to simplify this. Okay, what do? You just multiply straight, top and bottom. Now that 2 has to go on the outside of the root, though, right? It can't go in there. 3 times 7 is 21. This is root 10, because these are both in roots. They multiply, whereas this 2 is outside, so it stays outside. So that's it. 2 root 47 plus root 10 all over 21. We did it. There is the exact answer. They asked us for an exact answer, no decimals. We did it. So that was a lot of work. So the 4 steps then. So the first thing we did is we took the sine of A plus B and we wrote out the formula for adding two angles, right? Sine, cosine, sine. Plugged in the 2 we had, the 2 they gave us, and to find the other 2 we had to draw triangles for both the A and the B. Use the SOHCAHTOA to fill in what they gave us, then the Pythagorean theorem. We got all 3 sides of the triangle, then we can do SOHCAHTOA again to find what we need. Then we came down and we finished the problem. So there we go.